Hey everybody, got some good news and some bad news. Good news is there's only 3 lessons left, right? I don't think you or I have the time for everybody to do all this virtual stuff, and everybody's expecting to get everything done because you got nothing better to do, be honest. You're stuck at home, or you should be. Otherwise, you're the people we make memes about being stupid and not staying home. So, we're gonna start chapter 8. We're only gonna do the first 3 sections because I want you to be familiar enough with conics. Okay, so we're gonna do some conics in the course, and I just want you to be familiar with them. So we're gonna start with parabolas. So the good old parabolas, and we are going to kind of change it a bit. Okay, we're gonna take a different viewpoint of parabolas. So after this, chapter 8.2, we'll talk about circles and ellipses. And then chapter 8.3, we are going to look at hyperbolas. And that'll be it for the course. So what I'm going to do today is 8.1. And then a couple days later, you'll see 8.2. Now, next week, you're not going to see anything from me. Okay, I'm going to give you a work week where you're just going to get any work done for that week, because my wife is due and I'm not doing anything. You can try to ask me questions. Good luck. Okay, I might be busy. So we're going to start with 8.1, and I'm going to look at this, and then I'm going to make a separate section going over some like practice questions like we normally do in class. But I wanted to go over this PowerPoint to kind of introduce you and have you write down some notes. So feel free to pause and write down anything you need as we go through this PowerPoint. So chapter 8.1, conics, new look at parabolas. So we'll look at what conics are, what the conic sections mean, the geometry of parabola, translations of parabola, and reflective property of parabola. So again, why conic sections are passive nature. Any free moving object in a gravitational field follows the path of a conic section. Ha ha ha. So this would be astrological even. Now, again, here we have a right circular cone of 2 napes, where we have an upper nape and a lower nape. We have a generator where it's causing some circle here, okay? And they meet at a vertex, okay? Now, we have several different shapes that can be formed by the intersection of a plane and a cone, okay? So first is an ellipse, and that's if a plane diagonally intersects a cone. If you intersect a cone horizontally, you create a circle. So if you remember the equation of a circle, I don't know if you do, it is x minus h in parentheses squared, and I could write this down since I have the ability to do it. Well, there it is. So circles have a formula which is x minus h squared plus y minus k squared equals r squared. And then ellipses are a little bit different, okay, because they're not really have the same radius from a center. They have different focal points, okay. And then we have a parabola that we deal with. We have a couple equations for this. And then we have, this is the hyperbola, which is a vertical intersection of the 2 cones, where it forms 2 parabolas, basically, that are mirror reflection of each other. All right? So that's what we're going to deal with in Chapter 8. Here. I don't really think this is important. We're going to move on. Also, not something I think we need right now. Okay, so we're going to move on to just how parabola is formed. So here's some important parts of a parabola. Okay, we have, again, the vertex. We have the vertex. Okay, that's going to be given to us. Or we're going to be given a focus, okay, which is, again, a point we'll talk about in a moment. Talk about the points. So I think it was that all points in a plane are an equal distance from a particular line, the directrix, and the focus. So every point here on parabola has the same distance from the focus point, and that's terrible, to a perpendicular distance to the directrix. Now this right here, this line, is called the directrix. So these are going to be the important parts: vertex, focus, and directrix. So creates an isosceles triangle there. Isn't that nifty? All right, clear this. All right. So here we have a more standard set. Now, this is the graph of x squared is equal to 4py. So this is if the parabola is opening up or down, okay, in a vertical direction. Opening up vertically, opening down. We have x squared is equal to 4py. Okay, and that's the formula. This is the formula. You want to write this down. So you're going to want to write down this formula. Okay, very important. If it was opening horizontally, let's see if that's going to be on here. Not, I'll put it on here. Yeah, see, there you go. If it opens horizontally, it'll be y squared equals 4px. So the difference is, if it's y squared, it's opening horizontally. If it's x squared, it's opening vertically. Okay. Now, the importance of p here, p is the distance from the vertex to the focus and the distance to the vertex to the directrix. So this right here, this distance right here, this is p. Same as this. This distance here is p. So if we're given the vertex and the focus, we can find p by finding the distance to p, distance between, which means we may need the distance formula. D is equal to x2 minus x1 squared plus y2 minus y1 squared. However, if it's vertical, okay, if my vertex is the origin, okay, majority of the time, your parabola, if it's either going to open vertically or horizontally, it's not going to open diagonally, which means all you're going to need to note is what is the change, what is changing in the focus and the vertex. Okay, let me give you an example of that. All right. So we have an equation in the standard form of the parabola whose directrix is line of y equals 3 and whose focus is the point negative 3, 0. So let me draw this out to give you a better idea. Right. So we have x equals 3. Now if you remember, black, or whatever color this is that black? Okay. Don't know why it's coming out in that color. Okay. So we have x equals 3, which is again 1, 2, 3. Dash lined. This is the directrix. Focal point is negative 3. All right. So negative 3, 0. Which means P, your vertex, is always halfway distance between your focus and your directrix. So it happens to be that the vertex is at 0, 0. All right. So what's the change in the directrix or the focus to the vertex? So it's a change of 3. So P is equal to 3. Okay. Now this is opening to the left, which means 1 is going to be y squared, since it's opening horizontally, equals 4 times negative 3x. So y equals negative 12x. Y squared equals negative 12x would be your equation. There it is. So if it was opening to the right, that p would be positive. Okay. If it's opening to the right, p would be positive. If it's opening to the left, p would be negative. That's how you can tell p is positive or negative. All right. If it opens vertically, p is positive. If it opens, if it opens up, p is positive. If it opens down, p is negative. All right. We'll do some more examples in the homework of this. Okay. Let's look at what you need to write down to make sure you have this information. All right. This right here. This is your standard form. If it opens up or down, we're using this form. Left or right, we're using this form, where the vertex is at 0, 0. All right, so make sure you have that written down. We'll look at that. We'll need some of this later. All right. Now, what if the vertex isn't at 0, 0? All right. This is what we get. Now, this is kind of poorly done, so it needs to have a line of separation here. Oh, that's why. This is the separation. So this is up or down, and this is left or right. I mean by opening up or down, opening left or right. Up, p is positive. Down, p is negative. Left, negative. Right, positive. Right. So opens again. This is, if you remember, x minus h and y minus k. I don't know if we did circles, but h and k would be your vertex. That's not written here, so let's write it down here. Vertex, hk, hk. Just make sure you change the sign. So even though it's negative here, if it was, for example, x minus 2 squared equals 4p, I'm not going to worry about p right now, y plus 5, then it would be 2 negative 5 for my vertex. You just change the sign. Okay, same thing down here. Make sure you change the signs. The focus, if it's opening upward, is going to change the y value. If it's opening to left or right, horizontally, it's going to change the h value, or they change the x value. Directrix for opening vertically will be a horizontal line, which is y equals a minus p. If it's opening left or right, the directrix will be a vertical line. All right, and these don't change at all. Focal length. So, find the standard form and equation of a parabola with vertex 1, 2, and focus of 1, negative 2. Now, again, if they ever give us the vertex, it's super easy to find the change in p. What happened to p? It went from 2 to negative 2. So p is negative 4. That's the change from 2 to negative 2. It went down 4. The vertex is 1, 2, so that's h and k. P is negative 4. Now, if we graph this, we can kind of see how it opens. It open left, right, up, or down. So we have vertex at 1, 2, 2. The focus is 1, negative 2, which means it's going to be opening down. And this p is, again, like I said, negative 4, which means the directrix would go for the opposite direction, so it would go 4 up. This would be my directrix, which is x is equal to 1, 2, 3, 4, 5, 6. So that's the directrix. Vertex, focus. So we have everything we need. We have h, k, and p opening down. So we have x squared minus 8, so minus 1, equals 4 times p. Let me just write this out. X minus h squared, 4 times p, y minus k. Plugging everything in, x minus 1 squared equals negative 16, y minus 2. Done. That's all they want. You do not have to distribute, you don't have to simplify. We're done. Okay, so I want to say that's really everything for this PowerPoint. Clear this. So you were right. So there's your equation. And yeah, that's everything in PowerPoint. So you're going to see some practice questions as well. So you're going to see 2 videos, one for the PowerPoint, one for the practice questions. All right.